Hello and welcome to my graphing review lesson. In this lesson we will look at a circle graph, a line graph, and we will practice plotting data on a graph using examples from a scientific experiment. Let's start out with a circle graph. The instructions say the graph below shows the percentage of 5 minerals found in a sample of the igneous rock granite. And you can see the title, percentage of minerals found in a sample of granite. You can see here we have the graph as a circle graph or a pie graph. You can see the scale is numbered on the outside, and then the data is plotted inside using lines to separate the percentages. The question based on this graph is determine the percentage of orthoclase feldspar in this sample of granite. So if we look at our circle graph, orthoclase feldspar is here in this area, and it takes up this section of the pie chart or the circle graph. In order to find out the exact percentage for this, because it doesn't start at the 0 for the orthoclase feldspar, we're going to have to see what the difference is from this line on the graph to this line. For example, for quartz starts at the 0, and the other side of the slice is over here at this point, which would be 21. So it would be 21 out of 100, 21%. So the orthoclase feldspar, we're going to have to do the same thing. But in this case, it starts at 21. So that's what we're going to have to start with is 21. And it ends at 60. So if we subtract 21 from 60, we get 39. And that's 39 out of 100, which is going to be equal to 39%. Our next example, let's look at a line graph. In this case, this is a solubility curve. The x-axis here at the bottom, which is your independent variable, is going to be the temperature of the solution, going from 0 to 100 degrees Celsius, centigrade. On the y-axis, your dependent variable, your data, is going to be the solubility. How many grams of solute dissolved in 100 grams of water at those temperatures? And that ranges anywhere from 0 here at the bottom up to 200 grams. We've got 3 sets of data on here: strontium bromide, potassium bromide, and copper 3 sulfate. The temperature based on this graph is as the water temperature is increased from 30 degrees Celsius to 90 degrees Celsius, so that's going to be from this point on the graph to this point on the graph, how many more grams of potassium bromide will dissolve in 100 grams of water? So we've got 3 graphs here, but this question is only asking us about potassium bromide. So we can ignore the other 2 lines that are plotted here. And we're going from 30 to 90. So we're going from this point on the graph, and then if we follow the 90 up, we're going to this point on the graph. So we want to know how many more grams of potassium bromide will dissolve. Well, at 30, the value is going to be 70 grams. At 90, if we follow the graph over, it says 100 grams will dissolve in the water. So if we find the difference between those two, 100 minus 70, 30 grams more. 30 grams more potassium bromide will dissolve in 90-degree water versus 30-degree water. Let's take a look at another example here. For these next examples, you have these on your paper, and what I'd like you to do is follow along, please, and mark on your papers as I'm marking here on the smartboard. A car traveled a total distance of 240 kilometers between 8 a.m. and 11 a.m. The data table shows below the car's distance from the starting location at 0.5-hour intervals during the trip. So the trip started at 8 a.m. and lasted till 11 a.m. If it started at 8 a.m., obviously 0 time has gone by and 0 distance has been covered. And then you can see here every half hour, all right, here's the times, here's the amount of time. Every half hour they recorded how far the car was from its original position. From 0 to 3 hours, which matches our 8 to 11 a.m. And the distance from the starting location increased almost steadily through that time. So now it says on the grid below, make a graph using the data in the table. Place an X to show the distance from the starting location of the car for each 0.5 hour interval. Connect the X's with a line. So we're going to do X's on here. I'm going to make myself an X right here to work with. And let's look at what we're going to graph. So our first data point at 8 a.m. they had gone, or 0 hours, and 0 was the distance covered. So that's going to be easy. So at 0 hours, our distance is 0. So I'm going to put an X right there on the point 0 hours and 0 for the distance. Our next point at 0.5 hours, it had gone 55 kilometers. So at 0.5 hours, I'm going to go up here to 55. Now I'm going to have to figure out my scale here. Between 0 and 50, there were 1, 2, 3, 4, 5 boxes. So that means each box must be worth 10 kilometers. So if I want to go to 55, this is 50, this is 60, so I'm going to have to go halfway between. There's my next point, 55. Next, at 1 hour, we had traveled 90 kilometers. So at 1 hour, I'm going to follow this up until I get to 90, which should be one box below the 100 line. All right, this would be 90 here. So I'm going to put that there. Our next time at 1.5 hours, still 90 kilometers. So at 1.5 hours, I'm going to go up to the same height, 90 kilometers. Next, at 2 hours, we've traveled 142 kilometers. So at 2 hours, I'm going to follow this up to 140 would be here. 145 would be halfway, so less than halfway, so 142 kilometers. Yep, 2 hours, 142 kilometers. 2.5 hours into the trip, we were at 200 kilometers. So 2.5 hours is going to go up here to 200. That's already marked on the y-axis, so that's very easy to find. And at 3 hours, we're at 240 kilometers. So at 3 hours, we're going to go up here to 10, 20, 30, 40. And then don't forget it says connect the X's with a line. So at this point, I'm going to have to draw a line. I'm going to go from my first X to my second, from my second to my third, third to fourth, fourth to fifth, fifth to sixth, and all the way up to my seventh X. So there's my graph. My independent variable was the time. We already knew what times we were going to measure. The dependent variable is on the y-axis. That's the distance. We didn't know what the distance was going to be before we did the experiment because that's the data we collected. Remember, your data is your dependent variable and it goes on the y-axis. The independent variable is on the x-axis. We already knew that we were going to measure distance every half hour. So that would be the graph of this data. Let's move on to this experiment. We've got a chart here titled The Location of Hurricane Betsy, August 29th through September 10th, 1965. We've got a column for the date, a column for the latitude, and a column for the longitude. And the latitude and longitude are going to give us the location at 1 o'clock a.m. on each of these days. So the locations for August 29th through September 5th have been plotted on the hurricane tracking chart on page 15. Plot the 5 remaining locations on Hurricane Betsy shown on the data table by following the directions below. Place an X for each remaining location of Hurricane Betsy from September 6th through September 10th. Label each X with the appropriate date and connect the X's using straight lines to show the continuing path of Hurricane Betsy. So we've got September 5th here. That leaves September 6th is next, and it's going to be 28 north and 76 west. So once again, we need to have it. We're going to be writing with X's, so I'm going to put my X here at the top. Once again, my first point for September 6th was 28 north, 76 west. So 28 north, is going to be here. And we're going to go to 76 west. Here's 75. There's 76 west. My next point on September 7th, 26 north, 77 west. So 26 north, 77 west will be here, hitting this island. Next, 25 north, 80 west. So we're going to find the 25, go all the way out here till we hit 80, right on the coast of Florida there. Next on September 9th, 26 north, 85 west. So 26 north, all the way out to 85 west. So here we are in the Gulf of Mexico. And last, 30 north, 91 west. So 30 north is up here and all the way out past the 90 to 91 west. And the grid line is not there, but we can estimate based on where the grid line is here. We can extend that using a pencil on our paper. The next instruction said to label the X's with the dates. So we would go through and label each of these. So this was September 6th, September 7th, September 8th, September 9th, September 10th. Then it asked us to connect the X's using straight lines. So once again, we're going to be drawing lines. 4th to the 5th, 5th to the 6th, 6th to the 7th, 7th to the 8th, 8th to the 9th, 9th to the 10th. So we can see, looking here at the path of the hurricane, in this case, we had a grid set up using latitude and longitude. That's very similar to using an X and Y axis and using an independent and dependent variable, but in this case, we used it for a map. At this point, if you would like to go back at any point, you can rewind the video. You can take a look at each graphic individually again. Make sure that you did it properly on your paper. And then once you've watched this video and you've completed the handout, you are eligible to take the second graphing quiz as a makeup. Please see Mr. Phillips to schedule that makeup test. Thank you.